This is Module 6, Lesson 5. Read the objective with me out loud while I read it. I can investigate patterns in vertical and horizontal lines and interpret points on the plane as distances from the axes. All right, so we're going to go ahead and start with the application problem this time, just to mix things up. A company has developed a new game. Cartons are needed to ship 40 games at a time, so boxes, if you will. Each game is 2 inches by 7 inches wide and by 14 inches long. So 2 inches high, 7 inches wide, 14 inches long. Your job, how would you recommend packing the board games in the carton? What are the dimensions of a carton that you could ship 40 board games with no extra room in the box? So you need to figure out how big, if the game is this big, how big does the box need to be in order to get 40 games in there? So you need to figure out what the volume is of just a game first, and then figure out how big would the carton have to be if you wanted to put 40 of them into a box. So go ahead and sketch something out and tell me how big the dimensions are. So something by something by something. So the length times width times height of the box would be if you wanted to get 40 games in a box. Okay, so first sketching out the box, here's a game. Here's 2 inches by 14 by 7. So you could stack the games 10 high, put the games on top of each other, like 10 games high, and then make 4 stacks inside one box. So going off here, if I stack 10 games, that would be 2 inches times 10 would give me a 20-inch high box. Then 14 inches times 2, because I would have 2 this way. Then 7 inches, now I would have 2 on the width. So 2 times 14 is 28, and 7 times 2 is 14 inches. So the answer to our problem is 20 inches by 28 inches by 14 inches, the box to ship with 40 games inside. All right. Hopefully you did something like that, but yours could look totally different than mine. Now, the next part of our fluency is to practice multiplication using standard algorithm. Go ahead and do this and check on back to check. All right. So 1,395, 10,995, 1,081, 5,681, 26,355. Okay, the next part of our fluency is just to count by decimals. So first we're going to count by just 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's count by tenths starting at 0. So 0 tenths, 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 10 tenths. So 10 tenths is equal to what? If you had 10 tenths, it's equal to 1 1. Now, what I want you to do is write tenths 0 to 10 with words. So what does that look like? Do you remember? So 0 tenths, 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, and then what? 1. So now I want you to write the fraction equivalent to the decimals. What is the fraction equivalent to those decimals? So what is 0 tenths is 0, 1 tenth, 2 tenths, 3 tenths, right? So what does that look like? 0, 0. So 1 over 10, 2 over 10, 3 over 10, 4 over 10, 5 over 10 is a half, 6 tenths, 7 tenths, 8 tenths, 9 tenths, and what? 1. All right. Just a quick reminder of our last module. Now, decimals on number lines is our next part of our fluency. So what you're going to do is you're going to label the letters on the number lines, come back and check your work. All right, let's check our work. So A is 4.9, C is 4.7, B is 4.1, D is 0.2, F is 0.6, E is 0.9, H is 0.2 or 0.2 or 2 tenths. So it goes 10, 20, 10, 40, 60, 81. 20, 20, 40, 60, 81. 20, 40, 60, 82. So it goes up by tenths. All right, this is the end of problem set for lesson 5. I will start concept development on a separate video.